Hello, everyone. My name is Alicia, and I'm a research associate at the University of Sheffield. And also today we have Carolina, who is an associate professor also in Sheffield's NLP group. And we both work on vera.ai project, and we address the NLP side of this project. Probably because many of you have joined previous webinars, you are relatively familiar with what vera.ai project is about, but just in case, I will make a very brief introduction for those who are joining us for the first time. So vera.ai project has a very broad goal of developing AI-enhanced tools with the main objective of assisting media and fact-checking professionals in detecting misinformation. And we do it through the development of different multimodal verification tools, using existing AI models, but also enhancing and enriching existing models. But we also, our aim is not just to detect the misinformation that is already there, but act preventatively, so detect misinformation before it appears by detecting different types of coordinated behaviors, narratives that emerge in one country and then spread across different countries and different languages. Our consortium is quite large. We have 8 different research partners. The University of Sheffield is one of those 8 partners, but it also consists of 2 commercial organizations and 2 big fact-checking organizations. We have AFP in France and Deutsche Welle in Germany. And as many of you probably know, EBU is also part of the vera.ai project. So the University of Sheffield brings to the Vera project mainly its NLP expertise. And the goals that we tackle within this project are quite broad. So first of all, the first goal is to deliver multilingual, multimodal tools that are also explainable for misinformation detection. We also have the objective of developing the chatbot that would allow the users to understand the outputs of all of these models for video, audio, visual content, and textual content, of course, and also provide their feedback about the functionality of our tools. And finally, we work on the identification of different disinformation narratives that emerge across the world in different languages and different shared behaviors and campaigns. And on the left-hand side, you can see the Sheffield City Centre on a sunny day, which, talking about probabilities, as we will today, is quite a rare occasion, but I promise this image has not been manipulated. So the part of this that I will be covering in particular in this talk is related to the first point, which is the development of multilingual tools that are explainable in order to detect misinformation. And I will be mainly focusing on textual tools, although one of the tools that I will be covering is actually in between. It is about the translation of visual content into the textual content for further verification. And when we think about any type of content, let's say news articles or social media posts, as fact checkers or journalists or even the layperson like myself, we pick up on different clues in that content, such as the style, different argumentative features of the text that implicitly tells us that probably this piece of information is indeed misinformation. We broadly refer to those clues as credibility signals. For example, on the left, you can see this is the freely available tutorial that has been developed by Meta around March 2020, when there was a lot of fake news about COVID, and they specified different clues that people should pay attention to, one of which is, for example, sensationalist titles or checking the source of this information. The one in the center is the manual that has been created by Deutsche Welle. And here they say that people should pay attention to emotional claims, to the source of information, as well as the person who publishes this information, whether they are a credible source themselves, whether the information contains very sensationalist wording that is aimed to persuade the reader, and also to pay attention to different narratives and topics. And the one on the right is also the manual that initially appeared at factcheck.org, but currently there are different versions of this manual that are adapted to different domains, such as, for example, COVID misinformation and so on. And you can see that a lot of these credibility signals are actually overlapping, things like the source, the author, but also they suggest to check the date and also check information for different types of biases and framing, and also to check whether this information could actually be satire or a joke. So the tools that I will be presenting to you today, they relate to some of those credibility signals. In particular, we'll be covering opinionated content detection, sensationalist wording in the scope of persuasion techniques. We will be talking about the joke type of content or satire, and biases and framing. And so the first model that I want to talk about has been initiated within the data challenge. So in NLP, each year we have what is called semantic evaluation data challenge, where the organizers release some kind of a data set, and different teams across the world for a few months participate in developing different models. And then towards the end of this challenge, the organizers release the test set, and we evaluate our models and know where each team has placed in terms of the performance of those models. So this tool has been developed within the task of genre detection, and it covers 3 different genres of news articles. You can think of them as a very high-level classification of how objective the news article is. And of course, the objective reporting is what we would associate normally with trustworthy news, but also a lot of news can be opinionated or satire. So the initial training data consisted of 6 different languages: English, French, Italian, German, Russian, and Polish. However, the models that we developed within this task are multilingual. So in theory, they can work on all the languages, although we would expect them to work slightly better on the ones that they were trained on. And also within this challenge, we had 3 unseen languages that were Greek, Georgian, and Spanish, which would give us an approximate idea of how well the models would perform on completely unseen languages, the languages that they weren't trained on initially. So the approach that we used is very simplistic in its architecture. We just used an ensemble of transformer models. They were trained with different data splits, and one of these models was also multilingual transformer models, but we used the adapter setting, which means that it's the same model, but it uses less parameters. And there is a certain belief that such models generalize slightly better than the fully fine-tuned models. Now, the interesting part about our approach is that we noticed during the training that if we train the models for a certain number of iterations and just select the final model, it is not necessary that it will be optimal for all the languages, because different languages achieve its optimal performance at different times during the training. For example, you can see here that Polish is actually achieving its best performance very early on, before it's even reaching its 5th iteration, whereas some of the languages take much longer time in order to achieve the best performance. As you can see, for English, it takes on average 12 different iterations. And here we have languages like Russian or French that really achieve its best performance towards the very end of the training procedure. So what we did is we, on a held out data set, we evaluated our model after each iteration on each language, and we selected the optimal model for each individual language. And surprisingly, it resulted in quite good results in the official placing, because we reached top 5 in all of the initial 6 languages, and we also placed in top 5 in most of the unseen languages, including the 2nd place in Georgian, which has quite a high performance, which is very surprising because the model was not specifically trained on that language. The second credibility signal that we addressed was framing detection, and it was addressed within the same data challenge, actually. So we can think about framing as a way of presenting information from a certain perspective that can sometimes be biased. For example, if we are talking about COVID vaccination, and we know that there is a 0.001% of any side effects, we could be focusing on just that 0.001% and selectively choose the facts that support the idea that vaccines are causing side effects. But they can be different frames that we can define. So, for example, in this task, we define the following frames: economy and resources, religious and ethical concerns, fairness and equality, law, fairness, law and justice system, crime and punishment, security and defense, health and safety, politics, and international relations. And of course, these categories are not mutually exclusive. Even in short social media posts, it's very possible to come across different frames that are used in texts. And this is especially the case in longer news articles. And also, very often, the definition of framing is confused with topic. Even in our tool, for simplicity, we call them topics. But the main difference is that each topic can be presented from the perspective of different frames, whereas we cannot do it the other way around. For example, talking about COVID, we can discuss it from the lens of politics or international relations, health and safety, also ethical concerns, also the law, economy and resources, and so on. So the models that we developed for this task also consist of the ensemble. So here on the left, we have the monolingual ensemble, which we only used for our prediction on English data. And we found that it works better in general than the multilingual models. But for the multilingual models, we used the task adaptive pre-training and also adapters on top. So you can think of the task adaptive pre-training as the process of additionally training our models on the data that is related to a certain task or a domain. So a lot of these transformer models, they have been previously pre-trained on large amounts of data in order to understand what are typical dependencies, which word is usually following another word, and so on. However, they don't necessarily work very well in certain domains. So in order to adapt them, we kind of adaptively pre-train them on a certain domain, and then we also fine-tune them on a certain task. And in each setting, we had 2 models in the ensemble that use some class weights, because we have quite a lot of different categories, and one of them does not use any class weights. And as you can see, this resulted in quite good placing in English, which is the model that uses monolingual ensemble, but also from the multilingual ensemble, we also were in top 3 for all of the unseen languages, Spanish, Greek, and Georgian, and in top 5 for most of the seen languages as well. So the next tool that, the next credibility signal that I will be talking about is broadly called persuasion techniques. And you can think of a persuasion technique as a rhetorical structure that we use on a daily basis in different types of domains in order to manipulate the reader's opinions. Even people who try to stay conscious about different types of propaganda or persuasion can sometimes implicitly be persuaded using those techniques. As you can see, we can group them into 6 very broad types of techniques. I will just briefly go through each of them. One is called justification, when you justify a certain idea or a certain argument by appealing to some authority that said so, by saying that this is based on some popular opinion, saying that it appeals to certain values, moral values, social values, by also trying to say that a certain outcome is not favorable because of some fear or prejudice, or flag waving, which is using different patriotic and nationalist views in order to support a certain opinion. A lot of times people use simplification. So in the example with COVID, we saw that, for example, we can selectively just omit the facts that support the opposing opinion by focusing selectively on just the ones that cause our desired outcome. We can also create the situation when we say that there is absolutely no choice for the opposing outcome to be the case, or we are also able to oversimplify the causal relations, the consequential relations in our argument. A lot of time people use distraction, things like straw man, when I'm trying to argue against another person's argument. But what I actually do is I slightly modify what they say. So I'm arguing not exactly against their possibly valid argument, but my modification of their argument, which is not what they mean in the first place. Red herring, again, trying to bring another argument into the conversation that is not really related to the initial topic. And whataboutism, bringing some problem that, again, is not very relevant to the initial conversation. A lot of time people use things like slogans, that we need to act now, appeal to time, a lot of times when it is about some social movement, saying that there is no time, or a conversation killer. So when the argument is not going in a favorable direction, the person can just say that there is nothing to argue about, and without bringing any valid counter arguments, just end the conversation. A lot of time people also use manipulative wording, things like a lot of clauses that makes the statement very vague, very confusing to understand. Also repeating the same statement again and again so that people remember it as they read the article, and also exaggerating or minimizing certain causal effects. They also can attack the reputation of the opponent. Very often it can be expressed in things like name calling and or labeling the person with some words that are associated with negative sentiment, doubting their credibility, associating them with different groups that again have the negative sentiment. For example, if I associate a person with racists, then I am attacking their reputation and also saying that they are not very credible as a source. Bringing some hypocrisy to what they try to talk about, and also questioning their reputation in general. And these types of persuasion techniques, they are very broad, not just in textual information, but also in visual content. For example, on the right-hand side, you can see the ad that has been created by IKEA in order to sell their shoe cabinet. And as you can see, this is a very exaggerated type of the presentation. We can also often see some kind of advertisement of commercial goods that are associated with very social or moral values that we have, such as friendship, family. So this would be classified as appeal to values and so on. So for this task, we again trained 2 models. One was just a monolingual English model, and another one was a multilingual model. It was a very simple approach, and one of the tricks that helped us to achieve a very good performance is that in general, we noticed that the models tend to improve a lot when we include what is called the zero label information. So when the information, when we have in our training set some data that is labeled with a certain persuasion technique, you would assume that the model would perform better when it sees a lot of those persuasion techniques, but actually it tends to discriminate between different techniques much better when it is also presented with the contents that don't have any techniques present, so that it learns how to discriminate between true a positive identification of the technique versus no persuasion technique. And in this task, it was particularly important for us to achieve the macro F1 score because, as you can see, there is a lot of techniques, 23, and the data set is in general highly unbalanced. For some of the techniques, there would be just 1 or 2 occurrences in the test set. So technically, the model that would perform better on very frequent techniques could also behave very poorly on less frequent ones. So this helps us to average across different types of techniques. And as you can see, we were able to also place in a top 5 for most of the, for all of the scene languages. The final tool that I want to talk about is related not exactly to textual information analysis, but more to how can we translate visual information into the textual one. So in this particular example, it is a meme in German. And you can see that if the person doesn't speak German, it's very hard to understand what the meme is about. And how do we translate it in English or what it means. So what the tool consists of is 2 main models. The first is the detection of what we call text blocks. So within that image, we want to identify the parts of the image that we think represents text. And then after we identify these 2 blocks, we are mapping the characters that we identify within those blocks to different languages, and then we return the language with the highest probability. So in this case, it is German. This kind of tool is particularly useful in the current era of misinformation when we have a lot of platforms like TikTok that post a lot of visual content, but they also have textual information that overlays that visual content, and it can be in any language. So without understanding what this overlaid textual information means, it's very hard to detect misinformation on that kinds of platforms. So the way this tool can be used is, for example, making the screenshot of a certain TikTok and then passing it through the OCR module. And on the right-hand side, these are the groups of languages, not individual languages, but larger groups that it currently covers. So as you can see, it covers Telugu, Tamil, the group of Latin language, where German also belongs to, Japanese, Hangul, Han, Devanagari, Cyrillic, Eastern European languages, Bengali, and Arabic. And also in the best fashion of persuasion technique, I want to make a sensationalist claim that very soon we will be also adding Greek language to this tool. Probably within the next months, there will also be Greek language supported by our OCR tool. And again, the model consists of 2 main parts. So I don't want to go much into the detail, but we have the trainable and non-trainable layers of the model. And we evaluate different model families with pre-training and with also tuning the trainable parameters of the model. And as you can see, after we apply task-specific pre-training layers, after we train the layers using task-specific data, we are able to achieve the accuracy of around 95 for all of the models that we explored. So in the next part, I want to show how these models that I just presented are operationalized in the tools that we have within vera.ai project. So one of the goals of Vera project is not just to develop the models that fact checkers or journalists can use, but also to deliver the tools that are usable by our end users. And here we have some example. We have the We Verify plugin, which is a Chrome extension about which I will be talking in a little bit more details. We also have Truly Media that integrates some of our audio and video tools, the virtual assistant, and the database of known fakes that can perform the semantic search to understand whether certain claims have previously been fact-checked. Probably the most popular of these tools, at least based on the number of users, is the We Verify Chrome plugin. It is an extension that is freely available. You can download it using this link, and it can be called from any web page that you are browsing in order to verify the content of that web page. And as of yesterday, we have 100,000 users who already are using this plugin. It has also been featured in different news reports that are debunking news across the world. So this is the overall view of the plugin that is related to the textual information verification tools. So here, as you can see, you can provide the URL to the website or the web page that you want to check, or you can upload a local file. And here I have one example of the credibility signals panel that we have. The first is related to the first task, which is genre detection. And here you can see an article that dates back to 2019. It's about our Prime Minister at the time, Theresa May, and about the efforts to cancel the Brexit deal. You can see that in the first sentence, we state very positively that she achieved a breakthrough. And then in the very next sentence, we say that only it wasn't a breakthrough. So it is very clearly a satirical article. And one of the objectives of our methods within this task is to develop the tools that are not just black box tools that return the label of the article being satire. We want to explain to the end users why exactly the model decided to classify this article in a certain way. And here the user has a possibility to highlight the important sentences. These are the sentences that the model paid higher attention to, quite literally, because we are estimating it using the attention mechanism within our models. Within this text, and the darker regions indicate that these are the pieces of text that are particularly important for the model, and the model has higher confidence in these sentences. So here you can see that it bases its judgment based on the combination of the first and the second sentence. And it is particularly important for the model to have this second bit that refutes the first positive statement that we see at the beginning of the news article. The second group of signals in this panel is about framing, or we call it topic for simplicity detection. So here again, you can see that there are different framings that are identified within this article. This article is about international politics, so it's not surprising that here we have politics, international relations, law and justice system. And again, we have the explainability in terms of highlighting the most important sentences for the model and also indicating the confidence of the model in its prediction. And finally, we have the persuasion technique detection part of our module that contains a list of different persuasion techniques. that are annotated throughout the text. And you can also, if you are interested about a certain particular sentence within this text, you can hover the mouse over that sentence, and it will return you this panel with the techniques that have been detected. So here in red is the sentence that the user is clicking on, is interested in. And you can see that it identified different techniques. Not all of these techniques are the model is equally confident in. For example, the loaded language has lower degree of confidence, whereas it definitely detected dubbed and name calling. So the reason why it detected loaded language is because this is a very long sentence and it contains of actually two different clauses, two sub-sentences. It also highlighted dub because the very first part of this sentence mentions questions whether the Prime Minister has been acting in the interest of British people, and they say that it is the biggest question, so that's why the model identified is as adaptable persuasion technique. And also the Prime Minister has been called a stalking horse, which is a clear example of name calling and labeling people in order to achieve a certain degree of persuasion. Sometimes people can also be interested in particular types of techniques. So instead of looking at the whole text highlighted and annotated with persuasion technique, there is also the functionality that allows us to click on a certain persuasion technique and to highlight only the techniques that refer to this particular type of persuasion. So, for example, in this case, the user is only interested in fear and prejudice type of persuasion, and the tool just highlights these three sentences. So in the first sentence, it quite explicitly mentions the fears of the Brexiteers. So this is probably why this particular persuasion technique has been triggered for this sentence. In the second sentence, the author of this article is trying to say that EU has imperialist ambitions. So this is also trying to create a very negative and fearful type of persuasion narrative. And finally, in the very last paragraph, we can see that we are talking about blackmailing the British people to accept even the worst arrangements. So trying to persuade that any type of Brexit deal is not in favor for British people. So again, the author is here appealing to fear and prejudice in order to deliver their point of view. And this is the example with the OCR module. So here we have a very recent meme that emerged after a famous statement made by Donald Trump about eating the cats, eating the dogs. And here we can see that the model identified three different blocks of text. All three in this case are English text, but if that was not English, we have the functionality that allows to translate individual blocks into our native language. We also can copy the whole text that appears on the image and translate it or copy it for further translation using our internal systems. And we also have this reverse search functionality where we can upload this image and find very similar images using Yandex, Bing, or Google Lens. In this example, it is also the OCR module, but in this case, we have the airport signs that are shown in different languages. So here we have Czech, Italian, Russian, British, English, German, and Spanish. And for the first two blocks of text, the model has correctly identified the one on the right-hand side as Italian, and also the one on the left-hand side as Czech. And this is why it is particularly valuable to have this block-based approach towards optical character recognition in case we have the images that have a mixture of different languages. We can identify individual languages within those images and create a better idea about what the image is talking about. And finally, I will, if I have time, I will show you how these tools work in a real life scenario, because there are some other credibility signals that I did not cover in this talk due to the time limitations that have been developed by our partners. Also just some food for thought. These are the publications that are related to the tools that I have been presenting, but also probably the very natural question that we have is, if we have these individual signals, do they necessarily indicate misinformation, and can we automate it without having the journalist as a final instance in the loop? Can we automate the process of aggregating those several credibility signals? So this last publication is exploring this, where we used LLMs to predict 19 different credibility signals, and we then used the automated model to aggregate those signals, and we found that this model is performing particularly robustly when we are talking about out-of-domain information. So if we talk about trained models that are aimed at detecting misinformation in a certain domain, we often are faced with the situation when the model doesn't perform as well on the outside domain. For example, if it's trained for political facts, it does not perform very well on gossip or rumor detection. So unlike these models, our model is performing very robustly across different domains, which is particularly important. And it's also not relying on the training data, because it is predicting those credibility signals in a zero-shot manner. So we don't use any training data to predict the credibility signals. So I will now be hopefully you can see my screen now. I am in the interface of the We-Verify Assistant plugin. So this is the functionality that I showed you, where you insert the link, and here I'm showing the same article about Brexit. So as you can see in the first part of the interface, the tool is able to extract individual images that it detected on the web page. And you can further, so in this case, we don't have a lot of doubtful images that likely indicate manipulation, but if we did, you could click on this individual image and submit it to the other tools that are used for example, synthetic image detection that probably you saw presented in the previous EBU webinars by our Vera colleagues. Now, if we go down, you can see the whole text extracted here. And you can translate this text into another language of your choice by copying it or by directly using Google Translate. The next part refers to the named entity recognition. So here you can see the word cloud of all the named entities that have been identified in this particular text. And in particular, if you are interested in the persons that have been mentioned, it includes the names of people, the locations such as Brussels, US, Russia, and also the organizations that have been mentioned in this text. Here you can also see the URLs that have been extracted from this news article, and you can further cross-check these URLs, whether they appear in the databases of fake claims. Finally, this is the module that I have been presenting. It's called Broadly Credibility Signals. So here you can see the framing detection tool, and yes, you can also remove these explainability highlights if you prefer to. The satire detection part of the module, and here you have different types of persuasion techniques detected. And as I said, you can just, if you are interested in one particular sentence, you can just choose this sentence for further analysis. And we also have additional tools that have been developed by our colleagues. Some of them are, for example, here we have the tool that detects whether the text was machine generated, or, and in this case, it returns that it's very likely a human written text. This tool has been developed by our colleagues in Vera from Kinit. We also have the subjectivity detection part of credibility signal assessment, where you can look at the subjectivity of individual sentences. And again, we use the spectrum that explains whether the model is particularly confident or not about the subjectivity of certain claims. And finally, we have the functionality that allows you to detect whether certain claims have been previously fact-checked. So in this, using the databases that we have, and in this particular case, we can see that the model did not return any previously fact-checked claims. And now returning to the image part, for example, here we have the image that contains text. As you can see, I can run the forensic analysis of this image, and I can also run the OCR tool that for some reason, for this particular case, detected German. And if I want to explore this further, I can perform, for example, the Bing search that would return me the images and the websites that also use very similar images to this one. And I think that is all from my side, and I'm looking forward to any questions you may have.